So far in the course, we've studied two big classes of functions. Actually, it's two big subclasses of a big family of functions called polynomial functions. We've studied linear functions and quadratic functions, right? Lines, parabolas, etc. We are going to move up in degree. So again, linear functions are polynomial functions of degree 1. Quadratic functions are polynomial functions of degree 2. And so we're going to see polynomials of degree 3, 4, 5, and so on and so forth. And before we get there, though, we need to kind of refresh some skills that we maybe haven't used in a while to find zeros. As we saw in quadratic functions, zeros were super important. So we want to make sure that we are able to locate those zeros. And really what we're going to be using as we move into polynomial functions is this zero product property to help us find the zeros of a polynomial. And all the zero product property says is that if we have two things that multiply to zero, then one of them is zero, and that's actually how we find all possible zeros of the function. Okay, so we want to use this as much as possible, but in order to do this, we have to have it nicely presented as A times B, and it's not always presented to us that way. Okay, and so what we're going to try and do is get it into A times B by factoring. Okay, and so the first method that we're going to talk about with factoring is to try and use uh, a, a scenario where we are trying to factor out the greatest common factor. Okay, greatest common factor is just what is common to every single term. Okay, so we want to try and factor it out. We don't divide it out because if we divide, we lose the solution. Okay, so for example, if we want to find the zeros of each function here, again, zeros, we're looking for x such that f of x, which is y, is 0. Okay, so if we're finding the zeros, that's just saying 0 is equal to x squared minus x to the fourth. Okay, and in this first example, I'm wondering, okay, is there something common to both terms? Yes, there's an x squared in common. And when I factor out an x squared, it's a lot like dividing, but again, we're not dividing, okay, because we'd lose solutions. But you'd have 1 minus x squared, okay? If you remove an x squared from this term, or divide it out, you'd be left with 1. And if you divide x to the fourth by x squared, you just are left with x squared. And then at this point, you could set each factor equal to 0. So you'd have x squared is equal to 0. Yep. Or 1 minus x squared is equal to 0. Okay. And now you could square root both sides here, and you'd have x is equal to 0. Okay. Isolating the x in this one, you'd have 1 is equal to x squared. And then as you introduce a square root, you need a plus and a minus. So plus and minus 1 is equal to x. Okay, so I'd have the zeros that are 0, 0. Typically, we write these as coordinates 1, 0, and negative 1, 0 for this first one. There we go. Easy peasy, right? Let's go on and do another one. Okay, g of x. Set this one equal to 0. Okay, as I look at it, is there anything that's common to everything? Yep, there is. There's an x that's in common. So if I factor out an x, what am I left with? X squared minus 3x plus 2. Okay, again, just removing an x from each term. If you want to check that you're doing this correctly, you could always distribute that x to double check. And this, you could actually factor it further. We haven't, you might remember this from years past, but this would factor as x minus 2 and x minus 1. Okay, that's factoring trinomials. Okay, you might have to review the AC method, or some students learn it by a diamond or a cross method to factor this sort of thing. Whatever you learned it as, feel free to use that strategy. Okay, and now using the zero product property, okay, it actually says there's only 2 things, but it actually extends to 3 things or more as well. So we just set each factor equal to 0. X is equal to 0, x minus 2 is equal to 0, and x minus 1 is equal to 0, and solve each one. So we get 0, 2, and 1. Okay, and then I can write out the zeros as 0, 0, 2, 0, and 1, 0. Okay. H of x, next one. Set that equal to 0. Okay, and then I'm going to actually rearrange, because look at the degrees, they're out of order. Okay, so I'm going to say this is 4x to the fourth plus 4x cubed minus 4 x, or 24x squared is equal to 0. Factor out a 4x squared, okay? There's a 4 in every term, and at least an x squared in every term. And if I do that, I'm left with, let's see, x squared plus x minus 6 is equal to 0. Okay, and that actually factors further as x plus 3 and x minus 2. You can double check my work. Okay, distribute it out or do your other factor strategies. And then solving this, I get x is equal to 0, negative 3, and 2. Okay, so then I get the zeros as 0, 0, negative 3, 0, and 2, 0. Okay, so I have these zeros found. Okay, now there isn't always going to be a GCF, okay, greatest common factor. Okay, but what you can notice is that maybe some things have a GCF, right? So if I look at, say, the first two terms here, those have a GCF. Those have a GCF of x squared, and then I'd be left with x plus 1. And here, I could factor out a 3, or x plus, I'm sorry, that's x plus 4. And then here I'm left with x plus 4. Okay, this method is called factoring by grouping. I would chunk this expression, or this function, 2 terms at a time. Okay, this is all equal to 0 if I'm finding the zeros. Okay, and then in this setup, I can say, okay, well now I see that each term has an x plus 4, so I'm going to factor out that x plus 4 from these two terms, and I would be left with x squared plus 3 is equal to 0. Okay, and then I could solve this. X plus 4 is equal to 0, or x squared is equal, or x squared plus 3, oops, is equal to 0. And here I get x is equal to negative 4, and here x squared would equal negative 3, which is not possible, so I'm just going to say no real solutions. Okay, so my only real 0 is 4 comma 0 in this case. But the big idea was these first two steps. Okay, so if I look at it and there isn't a GCF in common to everything, I can chunk it 2 terms at a time if there are 4 terms or more, and see if those chunks have common factors. In the first chunk, I found a common factor. Second chunk, I found a common factor. And then in the next stage, I'm like, oh, hey, wait, there's x plus 4 in each. Factor that out, and here I go. Okay. Last example, I actually want you to pause video, try it yourself, and see if you can factor that and find the zeros. And here's my answer for that one. Okay, so this one, I actually did have a GCF to everything. I could have pulled it out in front. I was lazy and I did it later on. But I saw there were 4 terms, so if I had 4 terms or more, I can try factoring by grouping. So I chunked it. Okay, in each chunk, I removed the common factor. Okay, and then in the result, I saw, oh, the x plus 5 is in each of the chunks, right? Or in each of the factor chunks, so then pull out the x plus 5 and I have x cubed minus 6x. And then I said, oh, okay, wait, there's an x in common there, pull that out. And then now I was set up for the zero product property, and so I said each factor equals 0, and there I go. I was able to find my zeros. Okay, so in all, we reviewed a couple factor strategies just using the GCF and factoring by grouping, and a couple of these did make use of the fact, namely this one and this one, of our previous skills factoring trinomials. If you need to review videos on factoring trinomials, that is considered a prerequisite, but we are reviewing some general factoring strategies right now. So hopefully you can use these as we look at higher degree polynomials.